In this video, we're going to be taking a look at sunlight moving through air and hitting a body of water. There are several different results of things that may happen depending on how you view the rays of light. The first thing we want to know is that in air, we have an index of refraction of 1, which means that as light moves through the air, because the air molecules aren't very dense, the speed of light in a vacuum and the speed of light in air is about the same. And then in water, the index of refraction is 1.33, which it means it is a little bit more dense. So then as the light travels through the air and then enters the water, it's going to start to slow down. And that index of refraction is a number that's sort of gauging how much it's slowing down. It's actually the ratio between c, the speed of light, and then v, the velocity in that particular medium. So let's take a look at a bunch of different things that could potentially happen as the rays of light are striking the surface of the water. In our first case, if the sunlight shines directly in to the body of water perpendicular to the surface, it just transmits straight through without being bent. So as the light hits the surface of the water, it does actually slow down a little bit, but it just goes from one water molecule to the next and it goes straight down. So that's just a regular straight transmission. Where the ray of light gets transmitted from the air to the water. Now for our second case, I'm going to go ahead and put a dashed line here, which is called the normal. The normal is just a line to reference what happens with the rays of light, and it is a line that is perpendicular to the surface. So in most cases, the light is coming in at a particular angle, and we'll just call that angle theta. And then as it enters the water and begins to slow down, it gets bent towards the normal, and then it has an angle of refraction. So that's the case where most light rays hit the water and they get bent because they start to slow down going through the new medium. Now, what happens is oftentimes when we look in the water, things aren't the size that they seem unless you're standing directly above that object and you're looking straight down. Then you're going to see an object at its actual size. Now, typically what happens is when you're standing at an angle and the light gets transmitted out of the water, your brain is going to think that the object is closer than it actually is. So if we just reverse the order of these arrows, this would be like the light reflecting off of, we'll say, a fish, and then coming out. Your brain is going to perceive the light to be traveling in a straight line, and it's going to think that fish or that object is a little bit closer than it actually is, when in reality it's right down here. So that's why most objects look enlarged when you take a look at them inside the water, unless they are exactly below you in your line of sight. All right, so those are a couple of things that can happen. Secondly, when that light strikes the surface, we also have some reflection as well. And then I'll go ahead and finish labeling this one over here. We have some refraction because the light bends. Okay, now we have some reflection and some refraction, and then refraction is basically the light getting transmitted, but it's also getting bent as well because of the change in the medium and the change from the index of refraction going from 1 to 1.33. Now what happens is when the sunlight comes down and interacts with the water molecules get shaken up and transmit the light in multiple different directions, and some of it is downwards into the water, which is the part that's transmitted and refracted, or it gets re-emitted upwards, and we have some reflection as well. So if you take a look in the surface of the water or at the surface of the water, you will see some reflection from above, and then you'll also see some things below the water as well because of how the light gets transmitted through or reflected outwards. Now lastly, let's take a look at what happens with the color. Now, if you're taking a look at the sun, it's going to release all the different colors of the rainbow, but let me simplify and just breaking it down to the three primary colors of light. So we have red, green, and then blue. Now, when these three different colors of light interact with the water molecules, the water molecules are going to resonate most with this red frequency right here, and then the red gets absorbed. So now if a lot of the red is getting absorbed, the green and blue are going to have some reflection and some refraction. So it might have some of the light go down and get bent in towards the water. And then it also might have some that gets reflected out back into the air. So now if we're on the outside taking a look at the water, it's going to have oftentimes a greenish blue color in certain cases, depending on the clarity of the water. And when the green and blue are combined, it makes a color called cyan, which is basically just a greenish blue color. And that's the reason why when you take a look at the ocean or bodies of water that are fairly clean, they have that greenish blue color because the red and blue, or excuse me, the green and blue are getting reflected towards your eye, and a lot of that red is getting absorbed. So it turns out if there's red fish that are fairly deep in the ocean or a lake, they appear to be black because there's no red light getting to them for them to be able to reflect and appear red. So unless a fish is fairly close to the surface, they won't appear very red. But if they're sort of deep down, typically an ocean, not a lake, they're going to appear to be black because they don't have any red light to reflect. So to sum things up, we have a bunch of different cases where light can get transmitted straight through if there is no angle to be bent. If it comes in at a certain angle, some of it's going to be reflected off the surface and some of it is going to be refracted, which means it's bent because it's slowing down in that next medium of water. And then if we're taking a look at the colors, the three primary colors of light, we have red that is mostly absorbed into the H2O molecules, and those green and blues are being reflected or refracted through and then giving the water, the ocean, that greenish blue color. So I hope you learned something new from this video. Thank you very much for watching and listening.